there are certain rules to write or to take the positive or negative sign for the distances, then where we can measure the distance from. All these rules are called as sign convention. So the next important thing is mirror equation, which gives us the relation between the object distance and the image distance and the focal. Look at equation 1 and 2. In both the equations, the LHS are same, but RHS is different. Hello everyone, welcome to session 2 of chapter 9, Ray Optics and Optical Instruments. This is Swati from Vidhyaashram PRE-UNVERSITY College, the Temple of Excellence, Mysuru. So in this session, let us study about what is the relation between F and R. In the last session, we have studied about the basic terminologies related to mirrors. That is, what is focal length, what is radius of curvature, what is center of curvature, what is pole, and etc. Now we are going to derive a relation between the focal length and the radius of curvature. For that, I have considered a concave mirror of M and N. It is having a reflecting surface. Now, this is my incident radiation. So, there are certain rules to write the ray diagram. So, when the incident ray is parallel to principal axis, after reflection it will pass through the principal focus. F is nothing but principal focus. So, this is parallel to principal axis and after reflection it is passing through principal focus. This is the reflected ray. So, theta is the angle of incidence and this CM is nothing but the normal. Here let us write one more normal, that is MD, which is perpendicular to our principal axis. Now let us consider angle MCP, a triangle MCP, which is equal to theta, and angle MFP, which is equal to 2 theta. Now from triangle MCP, tan theta, what is tan theta? It is opposite divided by adjacent. So, according to this triangle, the opposite side is MD and the adjacent is CD. Similarly, from the triangle MFP, tan 2 theta is equal to, I am considering this triangle now. So, the opposite side is MD, or you can even consider it as MP divided by FD. Now, I will call it as equation 1 and this is equation 2. Now, for paraxial lines or paraxial rays, which means the rays which are very much closer to the principal axis, this tan theta will be equal to theta. We are just forgetting the function of tan because for the angles are very small. So, theta is equal to MD divided by CD and tan 2 theta is nothing but 2 theta, which is equal to MD divided by FD. Now, we have 2 theta is equal to MD divided by FD. But in the place of theta, I can substitute this value, that is MD divided by CD, which is equal to, again here it is MD by FD to my right hand side. Now equating this, we get, let us simplify this by bringing these two terms to the other side. So we will get 2 is equal to MD by FD in my right hand side into, this will be the reciprocal after it shifted to the other side. So CD divided by MD. Now MD and MD gets cancelled and we remain with 2 is equal to CD divided by FD. Since this D is very much closer to the pole, we can even write it as CP divided by FP. So what is CP? It is nothing but the distance between center of curvature and the pole, that is given by R. And FP is the distance between principal focus and the pole. It is given by small f, that is focal length. Now we will get 2 is equal to, in the place of CP, I am substituting R, and in the place of FP, I am substituting F. So from this, we can write 2 into F is equal to R, or we can even write it as F is equal to R by 2. Is the relationship between the focal length and radius of curvature. Now, to understand the ray diagrams or to write the ray diagrams, it is very important to know about the sign conventions, which are usually called as Cartesian sign conventions. So, what are Cartesian sign conventions? There are certain rules to write or to take the positive or negative sign for the distances. Then where we can measure the distance from, all these rules are called as sign convention. Let us now go through one by one. The first one is, all the distances are measured from the pole of the mirror. Say this is the mirror and this is the center of the geometrical surface, so we'll call it as pole. So all the distances are measured only from the pole. Now the second one is, the distance measured in the same direction of incident light are taken as positive. Say for example, the incident radiation is in this direction. Now if the distances are measured from the pole in the same direction of incident radiation, then the sign convention should be positive. Suppose if the distances are against the incident radiation from the pole, then it is nothing but negative. That is the third point. And the next thing is, the height measured upwards with respect to x-axis, that is with respect to the principal axis, and normal to the principal axis, that is perpendicular to principal axis of the mirror, are taken as positive, which means the height upwards the principal axis are always considered as positive, and the height which is measured downwards the x-axis or downwards the principal axis is negative. It is also very important to know about certain rules or the convenient ways to construct a ray diagram. So let us now understand one by one. So any two of these following ways or following methods or following rules are taken as the convenient incident rays. What are they? A ray passing through the center of curvature can be convenient to write the ray diagram. A ray which is parallel to principal axis is also convenient. A ray which is passing through the focus, or a ray which incident at the pole. So these are the four convenient ways. Any two ways can be considered to write the ray diagram. So let us understand all these things with the help of diagrams. The first one is a ray passing through the center of curvature, which is reflected back along its own path. Say for example, this is my incident radiation which is passing through the center of curvature. After striking to the mirror or to the surface, it will strike back again with the same path. So with the opposite direction. So this is my incident ray, and after striking it is coming back again on the same path. That is my reflected ray. This is for concave mirror. In case of convex mirror, it appears to meet at the center of curvature, which means this is the incident ray because it gets reflected again from this surface. Say for example, it appears to meet at center of curvature. After reflecting, it will again take its path in the opposite direction, but it will reflect back along its own path. The next one is a ray incident parallel to principal axis. See, this is the principal axis. Our incident ray is parallel to principal axis. Now, after reflection, it will pass through the principal focus. So this is the reflected ray. This is in case of concave mirror. In case of convex mirror, this is my incident ray which is parallel to principal axis. Say after this reflection, it appears to come from a focus because it gets reflected at this surface itself in case of convex mirror. So if you draw the imaginary line, it will meet at the focus. So this is the another convenient ray. So next one is a ray which is incident from the focus. This is the incident ray which is going from the focus. After reflection, the reflected ray will be parallel to principal axis. So this is the reflected ray. The same thing in case of convex mirror. Now this is my incident radiation which appears to incident through focus. After reflection, it will be parallel to principal axis. The last one is a ray incident at the pole of the spherical mirror. Say for example, this is my pole of a concave mirror. Incident ray is directly striking into the pole. Then it follows the laws of reflection. So it will reflect back with equal angle of incidence when the incident ray is struck directly on the pole. So this is also another convenient way to write the ray diagrams. So the next important thing is mirror equation, which gives us the relation between the object distance and the image distance and the focal length, which means the relation, the final expression involves the terms u, v and f, the relation between u, v and f, that is mirror equation. For that, I have considered a concave mirror. This is my principal axis. Let P be the pole of the mirror, which is the geometrical center. I'll place an object. I'll call it as A, B. The distance between object and the pole is U, that is object distance. Now the incident ray is parallel to principal axis. After reflection, it will pass through the focus. This is my reflected ray. I'll consider one more ray which is directly striking the pole. This is my incident ray. After reflection, it will pass again following the law of reflection. Now, I'll take one more ray which is passing through the center of curvature. I'll call this center of curvature. So, after reflection, this is incident ray. After reflection, it will follow its own path and which takes the opposite direction. So this is the point where all three rays are meeting after reflection. So this is where exactly the image will form. So I'll name it as A dash and B dash. Let the height of the object be H1 and the height of the image be H2. Now the distance between image and the pole is image distance. I'll call it as V. What is the distance between principal focus and the pole? It is focal length. And the distance between center of curvature, here is my center of curvature, here to pole is radius of curvature. So this is the ray diagram to derive a mirror equation. Now in this figure, let us call it as AM. It is the incident ray. So after reflection, it will come in this direction. Let MN be the mirror of spherical surface. AB is nothing but the object. AP is again an incident ray which is directly striking into the pole. And AN is nothing but the incident ray which is passing through center of curvature. So now from this figure, you can see that the triangle ABC, I'll consider triangle ABC and triangle A dash B dash C, they are similar. So triangle ABC and A dash B dash C are similar. For similar triangles, the ratio of heights to their bases are equal. So the ratio of heights, let us take the height of the object, that is AB divided by height of image, that is A dash B dash, is equal to the ratio of their bases. So base is BC divided by B dash C. So this is my equation 1. Let us consider the another condition, that is triangle ABP to pole. So I am considering another triangle ABP and A dash B dash P, here A dash B dash P. So in that also they are similar triangles and the ratio of their heights, that is AB, that's a height of object, divided by A dash B dash, that's the height of image, which is equal to the base is BP divided by B dash P. That is my equation 2. Now look at equation 1 and 2. In both the equations, the LHS are same but RHS is different. So we can equate the RHS, that is BC divided by B dash C, which is equal to, look at the RHS of second equation, that is BP divided by B dash P. Now let us reduce this to a simple form by substituting in a convenient way. So what is BC according to the diagram? So BC is nothing but BP or PB minus PC. So if you take the difference between PB and PC, you will get BC. So I'll just write it as PB minus PC divided by what is B dash C? It is PC minus PB dash. So I can write it as PC minus PB dash is equal to BP divided by B dash P. Now, using sign conventions, we know the rules to write sign conventions. So, using sign conventions, what is PB? So, look at this. PB, all the distances are measured from pole. If the distance is measured in the direction of incident radiation from the pole, then it is positive, or if it is measuring opposite, then it should be negative. Now, what is PB? It is U. U, but in a opposite direction of incident radiation, and hence it is minus U. Next, we have PC. So, what is PC? According to the diagram, PC, so C is nothing but center of curvature. Distance between the pole and center of curvature is R. Since it is in the opposite direction of incident radiation from the pole, then it should be minus R. So, we will get minus R. Next, we have the term PB dash. So, what is PB dash? According to the sign convention, it is PB dash. B dash is where the image form. So, this is the image distance with negative sign. So, we get minus V. Now, let us substitute all these things in the expression, that is equation 3. So, what do we get? PB is minus U minus, what is PC? It is minus R. So, we get minus R divided by, here PC is minus R again, minus, what is PB dash? PB dash is minus V. So, we get minus of minus V, which is equal to, here BP or PB, which is nothing but minus U. So, we get minus U divided by B dash P, that is nothing but PB dash, which is minus V. So, we get minus V. So, let us now cross multiply this after multiplication of the signs in the numerator and denominator in our LHS. So, what do we get? Minus U, minus into minus, plus R divided by minus R plus V is equal to minus U divided by minus V. So, let us cross multiply this now. So, we get minus into minus becomes plus, UV, plus into minus become minus, V into R is VR, which is equal to minus into minus plus. So, R into U is UR, plus into minus is minus, V into U is VU. Now, let us divide the whole equation by UVR. So, the above equation becomes UV divided by UVR minus VR divided by UVR is equal to UR divided by UVR minus VU divided by UVR. Let us cancel the same terms. UV gets cancelled, VR gets cancelled, U and R gets cancelled, UV gets cancelled. So, here we remain with 1 divided by R minus here 1 divided by U. So, we get minus 1 by U is equal, here UR gets cancelled. So, I remain with 1 divided by V. So, I will get 1 by V again minus, here UV gets cancelled and I remain with 1 divided by R. So, it is minus 1 divided by R. So, let us bring all R terms to one side. So, this minus 1 by R when it goes to the other side becomes plus 1 by R, and this minus 1 by U when it gets transposed becomes plus 1 by U. So, we get 1 by R minus 1 by R becomes plus 1 by R is equal to minus 1 by U becomes plus 1 by U plus 1 by V. Now, we have R in the denominator for both the terms. So, R, now 1 plus 1 becomes 2 is equal to 1 by U plus 1 by V. But we know that from the previous relation between focal length and R, so R is equal to 2F. So, I can substitute here in the place of R, I will get 2 divided by 2F is equal to 1 by U plus 1 by V. 2 and 2 gets cancelled and we remain with the term 1 by F is equal to 1 by U plus 1 by V is the relation between object distance, image distance and the focal length, or it is also called as the mirror equation. So in this session, we have learnt few important derivations, that is the relation between the focal length and the radius of curvature, Cartesian sign conventions, what are the convenient ways to write the ray diagrams, as well as the mirror equation. In the next session, we will learn some more interesting and the important concepts regarding ray optics. Until then, keep learning all of you. Thank you.